That's a very nice problem, guys. It says find the relation between x and y such that the point xy, I'm talking about this point x comma y, is equidistant from point 36 and minus 3 comma 4. So that's point B, which is negative 3 comma 4, and this is point A, which is 3 comma 6. We have this point A and this point B. All right. Now the condition is if the point P moves, I can see that the distance between A, that is PA, and PB is always same. It's 4.47 here. 4.47. If I move this guy, I can say the distance is being same, 3.35, 3.35. Wherever you go on this line, I can see the distance is same, 7.07, 7.07. So we understand the condition that the point P is equidistant from B and from A. Beautiful. Now let's understand the relation between x and y, what exactly this means to us. Now look at that point. I'm just taking the point P here, which is x comma y, it's a variable point, and that particular point it is negative 2 comma 11. So how is x and y connected? X is negative 2 here and y is nothing but 11. Now is there a connection between them? It is. I can see that it is nothing but the equation of this line, and the equation of the line is given by this thing, that is minus 3x minus y is equal to minus 5. So if I substitute the value of x in this case, I get negative 3 into minus 2. Minus of y is 11. Is that equal to minus 5? Let's see that. That's like 6 minus 11. Is that equal to minus 5? Yes. Minus 5 is equal to minus 5. It means what? The left hand side and the right hand side are equal. That is a relation between how x is connected to y at this particular point. And as I move this point places on the line, see the point can move. Let's say we take another point here. So I'll just take those points where we have exact values. The other point here is negative 1 and 8. So let's talk about that now. So if I say here at this point, the variable point x and y, x is negative 1, x is negative 1, and y is 8. Now, are they again connected? And how are they connected? That is minus 3x minus y is equal to minus 5. And that's the relation we know, which is the equation of the line. So let's substitute the value of x as minus 1 here. That is 3 minus 3 into minus 1 minus y is 8, you get 8 is equal to negative 5. So what you get here is 3 minus 8 is equal to negative 5, and I can see that minus 5 is equal to minus 5. It means yes, x and y are connected in this way. Wherever the point goes, if I substitute the value of x and y in this relation, okay, that is a relation between x and y, we can see that this equation is satisfied. So how do you find this equation is the question. Let's see that. Now we understand what exactly is talking about by a relation between x and y. Beautiful. So let's see how to do this problem mathematically and get this equation. Now what's given to me is find the relation between x and y. On what condition? And the condition that point P, that's point P is equidistant from this point. I took this point as A and this point is B. So it means what? PA should be equal to PB. Now I can see that PA and PB are same. It is 4.47, 4.47. Fine. So is that what will help us to get the equation? Exactly. So what is P here in this case? That is P. Let me take this as x2 and y2, and A I'll take it as x1 and y1. Why am I doing this? Because what I know is the distance, and this distance is same. Something is equal on both sides. So I can say PA is equal to PB. Right now if I take this as x2, y2, x1, y1, can I use distance formula? Very simple. I can find PA as x2 is nothing but x here, and x1 is nothing but 3. So the formula goes simply like the square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Alright, that's about PA. We'll come back to PB a little later. So right now we know that x2 is x, so I can write x minus of x1 is nothing but 3. So you have that 3 the whole squared plus y2 is y itself, this guy, and y1 is 6, so we get y minus 6 the whole square. You still have a square root. Alright, keep this in mind. Let's come back to PB. Now when I talk about PB in this case, let me take this as x1 y1, okay, and that is anyway x2 y2. So if I put the same formula, the distance between PB, and I know that P and PB are same, so the distance formula goes like the same thing, x2 minus x1 the whole square plus y2 minus y1 the whole square. Beautiful. So in this case, what is x2 now? x2 is x itself and y2 is y itself, but x1 is negative 3. So I can write that x minus of minus 3 the whole squared. I can write plus, yeah, there's another bracket here, y2 is y and y1 is 4. So I get y minus 4 the whole squared. So that's what we have to solve to get the equation. Now, the first thing to do is get rid of the square root. You know this, that's a simple drill we follow every time. We have square roots on both sides, square both sides are gone. I do have x minus 3 the whole squared plus y minus 6 the whole squared. That is equal to x minus times minus is plus. I'll get x plus 3 the whole squared plus I can write y minus 4 the whole squared. Open the brackets. That's easy, guys. Let's do that. So now we understand that is the equation after I expand this using a minus b the whole squared, and here you have a plus b the whole squared. It's just the formula I'm using to expand this thing. Now what is same on the both sides? I can see x squared is same, that's gone, and y squared is same, that's gone. If you have same things on both the sides of the equation with the same sign, you can cancel them up. I do have a 9 here and the 9 here, that goes off. What else is common? I cannot cancel these two guys. Why is that? Because this guy is a plus sign, this is a minus sign, so that cannot cancel. Right, now what else is there? I can see that I cannot cancel this, but I can still subtract. So anyway, let's take all the x terms and the y terms on the left hand side. So I do have minus 6x, and I'm taking this also on the left hand side, that becomes negative 6x again. You have a minus 12y already, and the 8y comes as plus 8y here. What else is left out here is 36. So let's do one thing, let's send this 36 on the other side, that becomes minus 36, and we have already a 16 here. Beautiful. So I can add these two things. That is negative 12x, okay, and that goes like negative 4y is equal to that is negative 20. Now is this something I can divide the whole equation with? Yes, I can divide the whole equation with 4. Yeah, I can do that. So dividing the whole equation with 4, you do get negative 3x minus y is equal to negative 5. Is that the equation we have here? Exactly. Or we can just change all the signs to give you 3x plus y is equal to 5. We can also do this. Beautiful.